Let's simplify this difference of radical terms. The square root of 325xy minus the square root of 117xy. With some simplification, we're going to be able to write this expression as one radical term. But be careful, make sure you don't make this mistake of saying that, well, this difference is just equal to the square root of 208xy, because 325 minus 117 is 208. That's not how it works. This is not true. You should remember that the square root of something is the same as an exponent of 1/2. So these square roots are really exponents, and exponents come before subtraction. You can't just skip over exponents and go right to subtraction, and that's why you cannot simplify in this way. If you're ever unsure in this sort of situation, you can try to create a simple example to help you see if you are right or wrong. If you're not sure if you can subtract like this, take a simple example where you'll know the correct answer, like the square root of 9 minus the square root of 4. You know you'll be able to figure this one out because 9 and 4 are perfect squares. And if you take those perfect squares, you'll know that this should be 3 minus 2, or 1. If you then try to apply this incorrect simplification to this expression, you would get the square root of 5, which is clearly not equal to 1, which you know is the right answer. And so then you can say, yeah, this is not right, we're going to have to do something else. And that something else is factoring. The square root of 325xy is the same as 25 times 13xy. And the square root of 117xy is the same as 9 times 13xy. Now let me tell you how you would come up with these factorizations quickly without resorting to a factor tree. First, 325 should immediately have you thinking about 25, because 25 goes into 100, thus it also goes into 300, and so it certainly goes into 325. And 25 is a square number, so you should really be thinking about these square numbers because we're in a square root. So it's going to help if we can factor out squares. So let's think about 25. Well, it goes into 100 4 times, so it goes into 300 12 times, so it goes into 325 13 times. If we look over at 117, the sum of the digits is 9, which is divisible by 3. So 117 is definitely divisible by 3. But again, we're in a square root, so it's going to be particularly nice if 9, 3 squared, is a factor of 117. Since 3 is a factor, we should check if its square is a factor. And with a little bit of thought, you can figure out that it is, because 9 goes into 90 10 times, and 9 goes into 27 3 times. 90 plus 27 is 117, and so 9 goes into 117 13 times. Of course, if those quick tips don't make sense, you'll get better with practice, and you can always just use a factor tree if necessary. Now that we have these perfect squares in the square root, we can take them out. 25 is a perfect square, so it comes out of the square root as 5. Because the square root of 25 is 5. Similarly, 9 is a perfect square, and it comes out of the square root as 3. Now we can combine the radical terms, because we have 5 square root of 13xy minus 3 square root of 13xy. They are like terms, so we can combine them. That gives us our final answer of 2, because 5 minus 3, 2 square roots of 13xy. We had 5 of them, take away 3 of them, that leaves 2. 2 square root of 13xy. Let me know in the comments if you have any questions about this radical simplification, and be sure to check out my Algebra 2 course and Algebra 2 exercises playlists in the description for more. Thanks for watching.
I'm the mathematical menace, the machinations of mankind. 2 calculators at the same time, hand signs and abacus, finger count and calculus. I'm a V to the T, my parameter the rapidest. Happens like this, my lecture's the most prominent, dominant. Call me to Morgan, I get the compliments. The union in together like any time that we intersect, 'cause my